So what we're looking at now is sampling distributions of a sample proportion. We were looking at samples and means, so now we're going to look at samples and proportions. So here is just some new terminology for you. You have P is going to be X, so that's the number of elements over the population. Okay, now this P with this little asterisk over it, that is going to be called phat, is what we call that. Okay, so that's going to be X, so the number of elements, and then N, the lowercase n, that's going to be the sample here. Okay, so if you look at this, you have phat is the sample proportion, whereas P is just the population proportion. So sample versus population. And then you have the capital X is going to be the total number of elements in a population with that trait, whereas the lowercase x will be the total number of elements in a sample with the trait. Then lowercase n is the total number in the sample, uppercase N, total number in the population, and then you have Q. So remember what we said here, you have P is, or we said in our previous lesson, P is going to be an amount with something, Q is going to be the amount without. Remember here that P plus Q is always going to equal 1. Okay, so let's say P is 30%, we would say that's 0.30. Then we would assume that Q is the other percentage. So 30% have something, then 70% don't. So Q would be 0.7. So they would always add to 1. Okay, so what we're going to do when we do these problems, we are assuming that the mean of the sampling proportion is going to be equal to the mean of the population. That's what this says here. So phat is equal to the mean of phat, which is equal to the mean of the population. Okay, so the mean's not going to change. Again, it was the same thing with our previous lesson. The standard deviation is pretty different here. So when we find the standard deviation, we say this is the standard deviation of phat. It's going to be the square root of P times Q over N, okay, and N being your sample size. Then z-score. So we're still using our z distribution table. Okay, so your z-score is going to be phat minus the mean of phat over the standard deviation of phat. Okay, so what all that means, we're going to do an example. So here's the example here. It should be on your handout. Suppose that the true proportion of Americans over 25 years old that have a 4-year college degree is 35%. Okay, so what we want to do here is we're going to say from this is a proportion of Americans 25 years old is 35%. So that's your P. So 35% have a college degree. We would say that's 0.35, which means the percentage that don't have a college degree is going to be what? You guys can go ahead and type that in the chat box. .65, good. Okay, so we have our P and Q. So we're going to be exploring this with different sample sizes. So find the mean and standard deviation of the sample proportion for samples of the following sizes. Okay, so for a sample size of 38, the mean is going to be still the same, 0.35, okay, because the mean of the proportion is equal to the mean of the population, which is 35%. The standard deviation changes based on the sample size. So the standard deviation calculation is the square root of PQ over N. So we have our P and our Q and our N. So we would say this is the square root of 0.35 times 0.65 over the sample size of 38. Okay, so we want to put that in our calculator. Now, let me see here. I can share my calculator. I have to stop it and then share it again. Okay, so you guys, I don't know if it's working. Share my calculator. Can you guys see my calculator? Okay, yeah, I don't know if that one's gonna work. So I'm just gonna go back to here. Okay, so I trust that you guys can do the calculation on your own. So we're just going to go ahead in here, and you can put this all in at once if you want. Just make sure you use parentheses. We're going to go 0.35 times 0.65. We're going to divide that by 38 and take the square root. So if you guys do that and you go 4 decimal places, that should be 0.0774. Okay, so you can do two things. You can go put this all in at once in your calculator, or you can go 0.35 times 0.65, divide by 38, and then take the square root. Okay, just make sure you take the square root in the end if you're going to go order of operations. All right, so this next one, you have a sample size of 75. Your mean of p hat is still the same, so the mean is not going to change. The standard deviation, however, will change. Okay, so this time instead of dividing by 38, we're dividing by a new sample size, which is 75. So I want you guys to go ahead and get that standard deviation real quick and then type it in your chat box. Good, good. So we should get a 0.0551. All right, now the next one we have, we're going to take this and do a problem. So if a sample of 75 Americans over 25 years old is randomly drawn, find the probability that over 40% of them hold 4-year degrees. So we want to find the probability that more than 40% of the population in this sample of 75 Americans have a 4-year degree. There's one little thing that we check for this. This won't be required in your homework, but in a real statistical study, we do want to check this. So the sample size times p is greater than 5, and the sample size times q is greater than 5. Okay, why do we want to do that? The reason why is the central limit theorem. Okay, remember the central limit theorem tells us that we have to have a sample size of at least 30 to have a valid statistical study. So this helps us determine if our sample size is large enough. So we go 75 is our sample size times our p, which would be 0.35. So 75 times 0.35 is 26.25. And then 75 times 0.65 is 48.75. So as long as these are bigger than 5, then we are okay. Okay, and they are, so we can proceed with the study. So here's what we want to do. We have to find p hat is greater than 40%. Okay, so the proportion is greater than 40%. We want to convert this into our standardized score. Okay, so we need the z-score for it. So our z-score formula is p hat minus p over the standard deviation of p hat. Okay, so our p hat is 0.4. So we would go 0.4 minus our p is 0.35. And then our standard deviation we found was this 0.0551. All right, so we're going to go ahead and do that calculation. And we'll go 4 decimal places again. What's our z-score there? There you go. Yeah, 0.9074. 0.904 is what I'm getting here. 0.9074. Okay, so then what we want to do here is our normal curve. So here's 0. And 0.9074 is close to 1, so it's probably going to be about right here. And we want it greater than that. So this is the area that we are looking for. So we can go in our Z chart if we wanted, and we can find the value and then subtract from 1, okay? Or we can put this in our calculator. So we would go in our calculator to the normal CDF function. And then this is our lower limit, so 0.9074. And then our upper limit would be a positive 99. Let me see if I share my entire screen. If I can pull that up here. Okay, let me see. There we go. All right, so second vars, normal CDF, and then we go 0.9074, 99. And that would be 0.1821. Okay, so that is our answer there. And what does that mean in context? That is going to mean that about 18% of the population, okay, is going to, there's an 18% chance that over 40% of the population in a sample of 75 Americans holds a 4-year degree. So that's what we are, the information we're getting right there. All right, let me go to another example. Here we go. And I'm going to create this in a separate video because I don't like to do super long ones. So I'm going to